Hey, it's Tal from LightTag. In this video, I'm going to give you a quick tour of suggestions, or what some people call pre-annotations, what they look like inside of LightTag, how you can engage with them, and a little bit about where they come from. So to kick things off, this is the standard annotation interface in LightTag. And in this case, the data set I'm looking at is a bunch of political tweets. And we're using fine-grained NER labels. So person, date, URL, country, handle, title. So a very thorough set of tags. And standard annotation, I might do something like, say, Trump is a person, but that's not correct, right? Trump University is actually an organization. So I have, here we go, org. And then I can continue on to the next example. So a lot of times it makes sense to make things go faster with pre-annotations. And LightTag can learn from you, but if you have a pre-existing model or dictionary or regular expression or whatever, you can upload that into LightTag and have that displayed to your annotators. And that looks like this, right? So we ran a few models, in this case 4 of them, and uploaded their results. One of them said that this is money and that's wrong. Another said that this is a URL and that's correct. And they both missed that this is, actually it's not a handle, so they were both correct. Let's see another example. So Hillary Clinton is a person. I can just press accept all suggestions and maybe reject this one. And that's a pretty fast way to annotate. So again, show all suggestions, accept all, go to the next one, and show all suggestions, correct, correct, correct. Great. So as you can see, pre-annotating is a very good way to make your annotators work much faster. It is at the risk that they'll be a little bit biased towards your models, so you have to make that trade-off. Now, there is another way to engage with models, and that's via kind of analytics and review. So let's look at analytics. Once I upload models, and as I said before, we've uploaded 4 of them, I can quickly get a sense of how often they agree. And the same for annotators, but right now we're talking about models. So in this case, we've uploaded Spacey's small NER model, Spacey's big NER model, the Zalando Flare model, and the Stanford Core NLP model. And when I say we uploaded the model, we didn't actually upload the binary of the model. We ran it on our data and uploaded those results into LightTag. And once we've done that, LightTag will instantly calculate the agreement between the models on the shared example. So it'll give us a percentage. How many examples did Spacey see in comment or annotations did Spacey make that the other model also saw, and how many of them did they agree on? So in this case, big and small both saw 455. They agreed on 346. Excuse me, so Spacey big agreed to Spacey small 346% of the time, and 76% agreement, right? Conversely, Spacey big, they should made 490 annotations. Spacey small agreed with it 336% of the time for an agreement rate of 72%. And then we can get finer grained details on that. So we can get precision and recall metrics on our models, which is kind of nice. So I'm going to filter by schema here, just to filter into my model. And then I can get those 4 models again, and then the count of true positives, false negatives, precision, recall, and F1. So this is very handy. But you have to ask yourself, well, how did you know what is a true positive and a false positive? And that's where review mode kicks in. So in review mode, we kind of get a list of here are all the dataset schema pairs that we've annotated, and tells me I have this many annotations to review. And every time when I step into review mode, it'll show me an annotation or a set of annotations that conflict. If they came from a model or multiple models or models and annotators, I as a manager just need to get to my golden source. So in this case, we have this conflict, and we're going to say that they're both wrong because we wanted 2 different annotations. Japan is a geopolitical entity, and so I'm going to accept that. And again, we have these date conflicts, so I'm going to reject because it's not exactly how I wanted it. Russia is a geopolitical entity. Okay, the Soviet Union. So this is interesting. One model said the Soviet Union, one model said Soviet Union, so this is my preferred one. And then one said Soviet is a GP and Union is a GP. So we have predictions from all 4 of them, I think, and we're going to accept this one as correct. So once I do this review mode, this is how I get precision recall metrics, because suddenly LightTag knows what is correct or not and can tell you that. So just to recap, these are the two ways to engage with pre-annotations and suggestions. The first one is to show your annotators pre-annotations to help them work faster. So no, yes. And the second way is through review mode, where we can quickly cycle through what one or multiple models said and get to a golden source. So just to add to this, I'm going to reject that. Once I do finish reviewing, or I'm happy, or I finished all of the data, I can download the golden source data from LightTag, and typically we'll see customers do one of two things with this. Either they'll use it as their golden source training or test sets. Oftentimes they'll use it to train a more refined model. So if you're kind of doing a process where we've taken 4 models like this, validated their outputs, we now have a very high quality pre-annotated data set that we can use to train a higher precision model. Pump that back into LightTag, do the review again, and in a few cycles to reach a very high quality model. And just to go over those analytics again, so we have intermodel agreement, that's over here. And we can filter that by schema, so models belong to schemas. We'll get into that in the next video, right? And I can look at my precision recall metrics, which are over here. And so again, I'm going to filter by schema to quickly see which models are performing. And the one last thing that's pretty cool that I can do is kind of zoom in. So sometimes knowing the precision recall isn't enough. I want to know exactly what a model said. So I can go into the drill down view, select a particular model, and then load all of its annotations from LightTag. So it gets better because not only can I load all of the annotations, but I can break them down by result. So if unvalidated, unvalidated, false negative, false positive, or true positive, and I can subfilter that, say, by tag. And then I can see, now we're looking at Stanford Core NLP's model, all of the cases where it made a false positive for, say, handle, right? So in this case, it annotated all 4 of these things as one handle, and we rejected it. For MISC, it's captured a quote, which we rejected, right? So that's some strange tokenization bug. For number, first we rejected, I don't know why we rejected this one, but we can always look it up in here. It seems like it was an incorrect rejection, which we can then use to fix this. And maybe the last cool feature here is that I can search the annotated text by regex. So like a really quick useful one is just to see who captured trailing white spaces or tokens. So the regex for that, trailing white space or punctuation. So the regex for that would be something like this: match any of space, period, or comma, and then the end of the annotation. Go, and then we'll get a list of all of the cases where, so United States ending with a comma, the act ending with a comma, etc. So we know that the Spacey model is doing this, and this is something that, the Stanford model is doing this, and this is something that we can correct. Of course, we can do the same thing with annotators, but I think that's enough for right now. Thanks so much for watching. Bye-bye.